Hi everyone, welcome to the video. Today we are going to solve course schedule. In this question, we are given n number of tasks which are paired in m number of pairs in this with having some prerequisite conditions, which means for a pair, let's say in example 1, 1 and 0, in order to finish the task 1, you should have finished task 0 beforehand and you'll have to return all the number of orders if there is particular order to implement to successfully do this to this course. And in the end, if you have returned a valid order, it will just accept it. And if there's no order possible, why I will tell you shortly. In that case, we will just return an empty list array, and driver code will itself print the no ordering possible, but we don't have to take care. We have to return an array or list in Python since I'm doing. So if there's a possible valid order, I will just return it. If not, it will do the job. Okay. Now, in order to understand this question, 1 and 0, 1 is dependent on 0. So first we have to do course 0, then we can do course 1. So we will return a list having elements 0, 1 in this order, 0, 1, and not 1, 0, because 1, 0 is not possible. Since we returned it, it will print 1 since we had returned an valid order. But example 2 will tell you a better example, better conditions. See, there are n number of tasks and m number of pairs, which means there are 4 tasks and 4 such pairs. For 1, you should have done 0. For 2, you should have done 0. For 3, you should have done 1. And for 3, you should have done 2. You can see for 0, you do not have any prerequisite. So you can do 0 first. Then for 1 and 2, you should have done 0, which we already did. Okay, now there's no such prerequisites whether we can do 1 prior or 2. We can take them in any order. So order can be 0, 1, 2 or 0, 2, 1. Okay, 0, 1, 2 or 0, 2, 1. But in order to complete that course 3, you should have done either the course 1 or either course 3. So if you have done 0, 1, 2, next will be 3, one possible order. Then if you have done 0, 2, 1, then it is 3, one such possible order. Okay, and we will return this order since it will be in possible order. In that case, it will print 1. The driver code will itself print 1. We do not have to take care of anything. But now you may be wondering, when will be the case when there is no possible order, when there is a cyclic graph. Let's say in example 1, if 1, since 1 is dependent on 0, but in the next pair, if it was given that 0 is dependent on 1, then it would have formed a cycle, 1 dependent on 0 and 0 itself dependent on 1. It would have been a cycle, and in no possible manner we could have completed this question. So we will solve this question, and we know if there is a cycle, we have to return an empty list. If possible order is forming, we will return it. Okay, now first of all, I will create an adjacency list. Why? In order to store all the prerequisites. Okay, don't give I. And for the range n, we will just create an empty adjacency list, and now we will populate it. Now for p in prerequisites, for any particular p in prerequisites, we will fill that in our adjacency array. If a course p1 is prerequisite for course p0, how we will do that? In this manner. So this line indicates that if course p1 is a prerequisite for course p0, we are appending it in an adjacency list format. Okay, now I will create an empty set of list. This will be our set. We will store all the, we will keep track of visited elements. Now we will create a result list in order to send a valid possible result if possible. If not, we will return an empty list as we discussed earlier. Okay, now I will traverse for all the elements in the this empty list. If this I is already not visited, this I is already not visited, in that case, added two visited elements, visited, and then perform DFS on it. Then perform DFS on it. Now you may be wondering why what I am passing in the DFS function. So in DFS function, I am passing two things. First, I is the current element which we need to check, current course which we need to check the feasibility of that particular course. Okay, and second, no parameter over here is path, path of all such courses, because currently it is I, but as we progress in our DFS, when we will formulate this DFS function in our code further, we will change the path, append the path. Okay, if DFS is not possible, when it will be not possible, when it returns a cycle. How we will solve it in seconds. Okay, in that case, if this DFS is not possible, return an empty list. Return an empty list, because if the list is empty, driver course will print no ordering possible. We don't have to take care of that. Okay, but if a result is possible, we will return, but in reversed order. Why reverse order? Because see, we have formed adjacency in a reverse manner, which means we are forming if one is a prerequisite for zero, and we have not formed adjacency in format that zero is prerequisite for one. Okay, so one, since zero depends on one, that is why it is an reversed order, and at the end we will just reverse it and send. Now I will form this DFS function. DFS function. DFS, it will be current variable, current course P, and path, all such path. Okay, now first of all we will check for I in adjacency of P, for every course which in adjacency of P. Okay, if I is already in path, which means if I is already visited. Why will I in path already without exploring? It will be in path already, which for this path. What is adjacency? In adjacency P, I is the, see, for any adjacency P. Okay, for any adjacency P, P element of this adjacency list, I is the course which is depends on. Okay, adjacency pth element of adjacency is dependent on I. Adjacency of pth element, this pth element, this P adjacency P is depending on I, which means it should not be in the path. If it is already in the path, which means there is a cycle. It will only be in the path already when it forms cycle. Okay. If it does form the cycle, just return false, because as we already discussed, if there's a cycle, there will be a dependent cycle and we won't be able to do course. Okay. Okay. Now, if there's not a cycle, then if I is already not in visited, this particular I is not in visited, then add it to the visited set of visited elements. Now if we will again check for this particular I, we will again check then whether this DFS is possible or not, whether there is a cycle or not. We will add this I element to the path, because I already mentioned when I was passing the parameters for the DFS in the main function, I discussed it that I is the current element. I mean, there are both their eyes. I should have taken any other element in this DFS function, but let's see. For the for this I in the main function is the current element, and this path, this list of I is the path of all the courses. Okay. Now The DFS, this I which as which now right now I'm passing, and now this path plus path was the initial path, and now I already appended this. I appended this newer element, that the element which it was dependent with the current, which the current element was dependent upon. Okay, if again this DFS is not possible, when it will not be possible, you may have guessed it, when there's a cycle. When there's a cycle, it won't be possible. In that case, we will return and will come out of our function. If if there was no cycle, then append this particular course p to the result and return true. Why I appended in the result? Because this suggests that there was no cycle, and this current course P can be taken without caring about its prerequisites. Its prerequisites have already been taken care of. So we appended this current course P in the result, and in the end, we just came out. We just came out as a true. Since this result will be, appended in the main function, it's in the scope. So let's submit it and test how far we have came. Yeah, it does the job. It does the job in pretty amazing manner. So I will again just quickly brush through it. So we have created a adjacency list, and which means this this course 0 p0 is dependent on p1. Okay, we created in that particular fashion in a reverse order. At the end, we checked for all the elements in the adjacency if there's a DFS possible or not. If DFS was possible, well and good, we will append it. We'll append that this course is possible to take without being whining about its prerequisites. But if it is not possible, then we will return false. When it is not possible, when there's a cycle, when there's a dependency cycle, then we won't be able to take this course. So I hope you enjoyed it. You may have learned new concept over here. Thank you. Have a nice day.